Now remember, in our last video, we said that a function relates an input to an output by a special rule. In this video, let's get some practice using a rule to find the outputs for some inputs. Before we start, you should be able to substitute. So I'm going to put a question right here, and I'd suggest you try it before moving on to the video. If you don't get it correct, then I would suggest watching my video on substitution. So if you notice here, I have a function f of x is equal to 2x plus 3. This means that our function is to multiply our input x by 2, and then I'm supposed to add 3. Because remember, the x in f of x stands for input. So for these functions, for f of 3, f of minus 3, these are the inputs that I'm going to be putting in. So in the first question, I'm going to be putting 3. Then in the second, I'm going to be putting minus 3, then t, and so on. Okay? So let's try that first question. So first, I want to put in f of 3. Just simply means that wherever I see x, now I'm going to put 3. So that's going to be 2 times 3 plus 3. And that's going to be 6. And 6 plus 3 is 9. For the second question, I want to find f of minus 3. So now, again, wherever I see x, I'm going to put minus 3. So that's going to be 2 times minus 3 plus 3. And that's going to be minus 6 plus 3. And negative 6 plus 3 is going to be 3. Because if I owe 6 and I get 3, now I'll have negative 3. Sorry, that would be negative 3. Now for the third question, for f of t, could you tell me what that output is going to be? Well, just like everything else, wherever I see x, I put my input. So now my input is t. It means wherever I see x, now I'm going to put t. So that's going to be 2t plus 3. And I couldn't do anything further here because these are unlike terms. Likewise, for f of t squared plus 4, even though this one is a little different, this function here, in this function, we're putting in both a variable and a constant. As a matter of fact, it kind of even looks like another function. But remember, once it's here, once it's in that input section, it's just telling us to replace x with what we see. So instead of writing 2x, we're going to write 2 times all of t squared plus 4. So when I do that, 2 times t squared is 2t squared. 2 times 4 is 8. And now I can combine 8 and 3 since they're alike. So that's going to be 2t squared plus 11. So the whole idea is that whatever we see in our input section, that's what we're going to put in our function. Now, if I go down a little bit, what if I had a different question? I said, for what value of x is f of x equal to 21? Now this question is a little different because whereas the others gave me the inputs and I was finding the outputs, in this case, I know my output. I know that my output is 21, and now I want to use that to find my input. So how would I do that? How would I go about doing that? Well, let me write down what I know. So I know that f of x, right, is equal to 21. And I know, based on what I was doing before, that f of x is really 2x plus 3. Since I don't know what the input is, I don't know what x is, I could write it back as 2x plus 3 is equal to 21. So if this is my output and this is my input, right, I could solve for x. If I solve for x, solving for x would give me the input. So solving for x to find the input means that I would isolate 2x. So here I just solve it like any other equation. So it means I'd subtract 3 from both sides. So minus 3 there, minus 3 there. So that means 2x is going to be equal to 21. Sorry, 21 minus 3. 21 minus 3, and that would be 18. And if 2x is 18, that means if I do the opposite to the other side, so I carry 2 over here, that means I'd be dividing. So that's 18 divided by 2, so that must mean x is equal to 9. Therefore, my input when my output is 21 is 9. And if I test it, it works, because if I check it here, if I say 2 times 9 plus 3, that's going to give me 18 plus 3, and 18 plus 3 is 21.